Hi folks, welcome back. I hope you're all doing well. Back in August 2022, which seems like an eon ago on the AI timeline, I covered a paper which looked at the capabilities of coding LLMs, things like Codex, at intro to CS, intro to programming type of questions. And the TLDR of that was that if you simply feed Codex a data bank of questions at the CS 101 level, it scores in the top quartile of a typical class. Now, obviously, the big question that came out of that study was, how in the world are we now going to teach an intro to CS or intro to programming class now that these coding LLMs, not just Codex, but even things like GitHub Copilot, are so common? And that's where this paper comes in. It has some of the same authors as that earlier paper and presents the first observational study of novice students using code generating tools such as GitHub Copilot. They ask two main questions. The first one is about how novices interact with tools like Copilot. And the second one is a more subjective question about how they perceive their initial experiences of using such a tool. The way they set up the study was they took 19 students enrolled in an introductory programming course. The language being used was C++, and to be honest, that was a bit of a surprising choice to me. I thought an intro to programming course would use something like maybe Python, but that's fine, let's go with that. The assignment that these students were given was to calculate what is essentially the neighborhood map of a Minesweeper game board. The input is a Minesweeper board configuration, and the output is that same board with the numbers filled in for how many mines are in the surrounding squares. The participants had 30 minutes to solve this problem, and a researcher sat next to them in the room and observed them as they were solving this problem and using Copilot to help them with it. And they observed several interesting and somewhat surprising usage patterns. The first thing they noticed was what they call a slow accept, where you don't right away accept the entire suggestion that Copilot is giving you, but you end up typing out the whole thing yourself anyway. And that sounds counterintuitive. Why would you type out something that is identical to the suggestion? But it goes to show that students felt unsure about very long suggestions from Copilot. They didn't want to drop huge chunks of code that they had not written themselves. As one student said, you might have code that works, but you have no idea how it works. They also observed a fair amount of backtracking, where the participant would accept a suggestion, but then immediately afterwards delete it. And the third pattern they noticed was adaptation, where students would accept the Copilot suggestion, but then spend a fair amount of time trying to adapt or change that suggestion to fit their local needs. The authors bundle these three behaviors, slow accept, backtracking, adapting, into a new LLM interaction pattern that they call shepherding. And the idea is that students are trying to coerce the tool to generate the code that they want or need. They also observed a fair amount of drifting, which is what happens when Copilot generates incorrect code, and that takes the students down a debugging rabbit hole. It takes them further and further away from a correct solution. Another very common complaint was Copilot suggesting large blocks of code and also making suggestions very often. The students found this very distracting. It keeps prompting you for stuff when you don't need it. It makes it difficult to read what you're typing. These are some of the things the students said. There have been other studies that observe how more experienced programmers use Copilot, and they have somewhat different usage patterns. They use it more as a tool for accelerating their programming, and that's something we're not seeing with novice programmers. So the authors give this interaction pattern the name drifting because the user is drifting from one suggestion to the next without directing the tool themselves. There were a number of cognitive difficulties related to the earlier complaint of making suggestions too often. Students complained that it can be confusing if it gives you a code suggestion, but you don't know what it does or how it does it. It's intrusive, it messes up my thought process, it keeps filling up the screen with suggestions. But there were also a lot of really positive responses. Things like, it read my mind, or where was this when I was learning programming? For some students, it felt like the barrier to learning programming was being lowered. Other students were happy how Copilot's suggestions taught them things they didn't yet know, and so they learned something new. I was a bit surprised to see that there was a good deal of self-awareness that there is a risk of over-reliance on tools like Copilot. It appeared in a full 1/3 of the observations. And this goes back to the issue that Copilot generates correct solutions usually, but not all of the time. It's not perfect. And so you still have to understand enough about the fundamentals of programming to judge whether a solution that is being suggested by Copilot is good or not. Going back to positive effects, many students were super happy with how much faster it got them programming. They were really happy with avoiding syntax errors, which tends to be a major trip up for novice programmers. It just gave me the syntax and all I had to do was proofread. On the flip side, some students felt like actually typing out the code, even if it's really simple, is valuable for learning the syntax of that programming language. And if Copilot makes you skip that, it might actually hinder your learning. And speaking of AGI and Turing tests, many students perceived Copilot as having some sort of agency, as actually being aware. It kind of feels like it's generating what I'm thinking. It read my mind. I thought it was weird that it knows what I want. These observations lead to some interesting suggestions for how Copilot could be improved to make the experience better for novice programmers. The first suggestion is to be able to have more control over the prompt. Students often complained about suggestions popping up too often, or when they didn't want to see a suggestion. And this might be fine for more experienced programmers, but it tended to be a distraction for novice programmers. You may even want to hold back suggestions and let students attempt to solve the problem on their own, a little bit at least. Students were also sometimes confused by very long suggestions, and so shorter suggestions might actually be better. The second big theme that emerged from a lot of these observations was that often students were confused by both the generation capabilities of Copilot as well as the code that it generated. They often couldn't understand why the code was doing what it did. And so for novice students, it would be helpful to understand what the model is doing and for the model to be able to explain its output. So overall, the two big takeaways were that the authors found these novel classes of behavior when interacting with coding LLMs. The first one was shepherding, where students try to coerce Copilot to generate the code they want. And the second one is drifting, where students don't have a concrete goal in mind and they end up backtracking or deleting suggestions or just cycling from suggestion to suggestion. There is still an open question about where all this leaves us when considering introductory programming teaching. Some other studies have shown that the output of these AI code generators often does not get flagged from plagiarism detection tools. And we've already seen from a previous study by these same authors that if you simply give the questions to Copilot or Codex, it ends up scoring in the top quartile. So how are teachers and universities going to adapt their plagiarism standards or academic misconduct guidelines to deal with these new tools? And it's not a very simple or straightforward question to decide, because a modern IDE already offers tremendous amounts of help to a programmer, even without AI or LLMs. There's an interesting philosophical question about the ship of Theseus argument. What fraction of the code must actually have been produced by the student doing the assignment? So overall, this was a really interesting study that moves forward the discussion of how to accommodate these new tools in computer science pedagogy. But there are still a lot of open questions. I hope you enjoyed that, and I will see you next time. Thank you very much.